This is Dr. Tina Cannon from Chattanooga State. In this segment, we're going to be looking at hypothesis testing, how to use the TI calculator to test a claim about a proportion. And what we want to do is we want to look in the course, and we want to use a handout from calculator instruction in Unit 4. And we will go to hypothesis testing proportions. In this handout, there's a problem that deals with proportions. It says, a spectator claimed that the coin used to select the starting team in a football game was loaded. To prove that the coin was not loaded, an experiment was conducted to see how many times the coin landed heads up. After flipping the coin 350 times, 165 flips were heads, 185 flips were tails. Does this result support the claim that the coin was loaded? Now, if you think about the probability of getting a heads and a probability of getting tails when you flip a coin one time, that would be 1/2 or 0.5. So the probability would be 0.5 on a normal coin. The spectator has made a claim that this coin was not fair. So what we need to do is we need to take this problem, and we're going to go step by step of how to test the claim to see if it is accurate based on the sample that was conducted. Now, first of all, we always have to write our null and our alternative hypothesis. The null always has an equal sign. The alternative never has an equal sign. It's either not equal, greater than, or less than. So in this particular case, the claim was that the coin was not fair. If it's fair, it means it equals 0.5. So P equals 0.5 will be our null, because the null always have to have the equal. The opposite of an equal is a not equal. So the claim that the spectator is making is that the probability of the coin would not equal 0.5. So that would be our alternative. Now these are important when we do our hypothesis testing. So that's the first step. Write out your null and your alternative. Now the next thing we want to do, we want to call up the calculator, pull it up, and turn this on. And what we want to do is we want to go to Stat, move over to Test, and we want to go down to where it says 1 proportion z-test number 5. And this will come up on the screen. Now we have to fill in the information. The P comes from your null hypothesis. If you remember, the hypothesis, the null was P equals 0.5. So we're going to put in 0.5 into the calculator. Now, the X would be based on the claim. So let's go back to our problem and see what this says. Notice, to prove the coin was not loaded, an experiment was conducted to see how many times the coin landed heads up. So that would be considered a success if it lands on heads. So our N will be the total number of times that the coin was flipped. So that's 350. That's the N. Our X is going to be the number of times that it landed heads up. So that's 185. So in our calculator, we want to, X is 185. Let's see. No, I'm sorry. What is it? 165. And the total number will be 350. Okay. Now the next part comes from your alternative statement. You have to select, was the alternative a not equal, a less than, or a greater than? In our case, it's a not equal. So we move down to not equal and push enter to highlight this, and then we want to calculate all of our statistics that we need to answer this question. Okay, so this screen comes up. Now we're going to move down, and you can see all the steps of doing what we just did. And what I want to do is look at these different parts. Okay, first of all, this is the screen that come up on this. So we're just going to look at this screen that we have here. Notice it, the output screen. The calculator, notice it's showing us that our alternative was 0.5. our test statistic, our z-test statistic, which you can do by hand. There is a formula. If you want to do this by hand, you can use the formula. It's on your formula sheet. But the z, or the test statistic, is a negative 1.069. Okay. The next thing is our p-hat. Okay. This is the part that we're going to use to test our statistic. The p-hat, the 0.471 is the p-hat. The p-value is 0.285, okay, p-value, and then the number in the sample is n. Now, what happens is when we work with this, I have a picture drawn for you to help you see this. Since it's a not equal, that means it's a two-tailed test, a not equal, and in our z, it's a negative 1.069, which will be located here, and a positive 1.69 will be located here. Okay, the area under these two tails is the p that we have is 0.285. Okay, now what happens is to test this, we're going to use what we call the p-value method in hypothesis testing. Okay. What happens in this particular problem, we were not given a level of significance. Now, if you remember back in the section where we dealt with proportions, if your probability, or with probability, if your probability is less than 0.05, there was a, remember, it was unusual. Okay. In this particular problem, if they do not give you an alpha or a level of significance, you can assume it's going to be 0.05. If they do give you one, then you'll use that. But what we want to do is we want to compare our p-value to our alpha. Now, if you go back, your p-value is 0.285. We want to compare it to our alpha. In this case, we're going to use 0.05. Well, if we do, we see that our p-value is greater. Now, this is very important, and you may want to write this down. If the p-value is less than or equal to alpha, you reject the null hypothesis and conclude that the sample data support the alternative. If the p-value is greater than alpha, you fail to reject the null, and you conclude that the sample data are not consistent with the alternative. Okay, so the two things you're looking at, you're looking to see p-value is greater than or less than alpha. Well, in our case, alpha is 0.05. Our p-value is 0.285. That is greater. Now, if you look at this, if the p-value is greater, then we fail to reject the null. So let's go back up to our original problem. If you look at the original, where is it? Here we go. We failed to reject the null, which says the probability is 0.5, which that means we reject this claim, or the data does not support the claim. Let's put it that way. So in this case, we are going to accept this. Now, to make a formal statement, what we want to do is we want to look at something else that's in your course. If you go to Student Resources, go to the Formula and Tables, pull this up, down at the, let's see, here we are. This is how we're going to state our claim, our hypothesis state, our final conclusion. We'll get this right in a minute. If you look at your original claim, the original claim said that the spectator claimed that the coin was loaded. He did not think it equaled 0.5. So the question on this is, does the original claim contain equality? Well, no, his did not. Do we reject the null? In our case, we failed to reject. So what that tells me, and this is how you can write out your final conclusion, there's not sufficient sample evidence to support the claim that the coin was loaded. Okay? If you go back to this handout, you can see down at the bottom, this is written out for you somewhere. Here we go. Here's our claim. So notice the claim. The coin is loaded. Okay, that's what they original claim. Notice P is the proportion of trials that the coin landed heads up. Okay, so in our case, and it was defined as heads, not tails. Okay, in your original problem, that was a success if it landed on heads. Now, P equals 0.5 was our null. The alternative was not equal to 0.05. This corresponded to the coin is loaded. He was saying, hey, it's not equal to 0.05. What happened was we conducted a two-tailed test because the alternative was not equal. If it's a greater than, that'd only be one tail. If it's a less than, that would be one tail. But an alternative is a two-tail, okay, or not equal to in our alternative. Now, what happened was when we compared this p-value, we saw that it was greater than 0.05. It was not less than. If it's less than, we reject the null. If it's greater, we fail to reject. And so then, since we fail to reject what this is saying right here, that means we do not accept this part. So there's our final conclusion from our flowchart. There is insufficient evidence to support the claim that the coin is loaded. So this it comes in steps. It's best to take this thing in steps. You need to write down the claim, write down what's considered a success, then write your null and your alternative, run the test on it, and write down all your information. And then you have to decide, is p-value greater than or less than alpha? And then you have to go look at your flowchart and make a final conclusion. So these are the steps that you use every time in testing this. If you notice back at the beginning, this 0.285, the calculator has already split the areas in half for you. If you were really going to do this by hand, you would have to calculate your z-score and then go look up your probability, and then remember that it's area and two tails, so you'd have to split it in half. Well, the calculator does that for you, so you just use the p-value that it's given you. So this is an example of how to test a claim about a proportion.